Hey everyone, and welcome back to the channel. Today we're looking at a new video model from the Adobe research team called Self-Forcing. This open-source AI video generation model introduces a pretty interesting training method. In simple terms, the self-forcing model learns to create video by looking at its own previously generated frames during training. This helps it get better at making longer, more consistent videos because it's learning from its own mistakes. One of the best things about this is how fast it can be. On a high-end GPU, it can generate frames in a streaming fashion, which opens the door for more interactive video generation. If you check out the model's page on Hugging Face, you'll see a few different versions available, like self-forcing DMD and a couple of self-forcing SID variants. It's worth noting that this model is released under the attribution non-commercial license. This basically means you can use it, share it, and even build upon it as long as you give credit to the original creators, don't use it for commercial purposes, and share any modified versions under the same license. I've put together a straightforward custom text-to-video workflow, as well as an image-to-video workflow with VACE that uses the self-forcing DMD model. To make it more accessible for those of us with less powerful hardware, it also uses a lightweight GGUF clip model. This should help with faster generation times on devices with lower VRAM. I'm running it on my laptop with a 6GB RTX 4050, and it generates 768 by 640 videos in just a few minutes. All the links for these workflows will be down in the description. As usual, I'll walk you through how to get the new self-forcing models and the workflow set up manually in ComfyUI. We'll also take a look at a RunPod template that will let you run these models on faster cloud GPUs without much hassle. And for my Patreon members, I'll also include a one-click Windows installer that will download and set up everything for you. You can find that over on my Patreon page. Don't forget to like and smash that subscribe button so you don't miss out on more great AI content. Alright, let's get this set up. If you decide to use my one-click Windows installer, the process is incredibly simple. Just download the self-forcing ComfyUI batch file, create a new folder for this project, and drop the file inside. Double-click the batch file to run it, and it will handle everything else. It installs ComfyUI, all the necessary custom nodes, and downloads the models directly into that folder. Once the script finishes, go ahead and start up ComfyUI. Download the workflow file from the Patreon post to your computer and load it into ComfyUI. From there, you should be ready to start generating. Now, for those of you who prefer a manual installation, you'll need to have ComfyUI installed first, along with the ComfyUI Manager node, which makes adding the other nodes for this project much easier. For Windows users, you can grab the portable version of ComfyUI from their official repository. It comes with everything needed to run. Just download the zip file and extract it using a program like 7-Zip. To install the ComfyUI Manager, open a command terminal, navigate into your ComfyUI directory, and then into the Custom Nodes folder. From there, you'll just git clone the ComfyUI Manager repository. After it's cloned, go back to the main ComfyUI portable directory, the one containing the Python embedded folder, and run this command that you see here on the screen that I will leave down in the description. That will install all the required dependencies for the Manager node. Before we fire up ComfyUI, let's download the models we need. We'll be grabbing the self-forcing model itself, the UMTT5 Clip GGUNF model, and the WAN 2.1 LiteX2V Distill LoRA model. This LoRA was created by the developer Kaiji, who's well known for creating some fantastic ComfyUI extensions and optimized models. This particular LoRA helps us get faster generations in as few as 4 inference steps. We also need to download a self-forcing VACE model, which will allow us to use a reference image to guide our video generation. This is a 1.3B experimental model, but it comes in compact FP16 and FP8 sizes that are perfect for consumer GPUs. To get the self-forcing models, head over to Guandi's Hugging Face page. I'll have it linked below and click on the Files and Versions tab. You'll see a few different model versions you can try. Feel free to download them all to see what works best for you, but in my testing, the DMD and SID V2 models gave me the best results. For this guide, I'll be downloading the DMD model. For the WAN 1.3b self-forcing vase, you'll go to the LIM00 Hugging Face page and pick the model that best fits your hardware. For the T5 Clip GGUF model, we will head over to the City96 Hugging Face repo for the UMT5 Encoder GGUF model and download the 5km GGUF clip model for our workflow. If you have more compute resources at your disposal, you can elect to go for a higher GGUF quant like the Q8, which could help provide better performance. And for the WAN 2.1 Litex2V Distill LoRA, head to Kaiji's Hugging Face repo and download the file, which is about 317 megabytes in size. We still need a VAE model, but we can grab that easily inside ComfyUI Manager in a moment. Once you have the models downloaded, just drag the self-forcing model and the vase model into your diffusion folder, the clip model into the clip folder, and the LoRA model into the Loras folder. Now you're all set. Go ahead and start up ComfyUI. Download the workflow file from the link in the description and drag it onto the interface to load it. If you see any red nodes, that just means you're missing a few custom nodes. Go to the ComfyUI Manager on the right side of your screen and click Install Missing Nodes. Install each missing node one by one. While we're here, let's get that VAE model. In the manager, just type WAN VAE and download it. After everything is downloaded, click the Restart button to finalize the installation of the new nodes. Once everything is installed and restarted, take a moment to check your model loader nodes. Make sure the correct models are selected by clicking the drop-down arrows. You should see two main sections in the workflow, a text-to-video section and an image-to-video section. For text-to-video, it's as simple as typing your prompt in the positive prompt box, and you can leave the negative box empty. Once you have those values in, hit the Generate button. For the image-to-video section, you'll need to upload an input image to be used as a reference. Then in your prompt, describe in detail what you want to happen in the video, making sure to involve the subject from your image. When you click Generate, the model will try to incorporate the subject from your picture into the new video. On my RTX 4050 with 6 GB of VRAM, generations usually take a couple of minutes, with a few extra minutes for the VAE decoding process. The quality isn't state-of-the-art just yet, but the model is likely to be updated, and we might see a better vase model from the original creators in the future. I've also set up a RunPod template for those of you who need more power to run this workflow faster. RunPod offers everything from H100s and RTX 4090s to A100s, each with a different per-hour cost. Just click the RunPod template link in the description. If you don't have an account, you'll need to make one. Once you're logged in, select a GPU. I'd suggest something with at least 24 GB of VRAM, like a 4090, for the best speeds. You can edit the template storage by adjusting the container storage, which is temporary space for your pod, and then click Set Overrides. Once your settings are good to go, click Deploy. Your pod will start building and will run scripts to install everything needed. This usually takes about 15 to 20 minutes. You can watch the progress in the logs file. When you see the final script showing a local URL in the terminal, you'll know it's ready. A good rule of thumb is that when the storage for the ComfyUI template hits about 53% capacity, the installation is typically done. Once it's finished, click the Connect button on the bottom of the pod menu. The template includes built-in access to Jupyter Lab, making it easy to access ComfyUI's project files. Simply tap the Jupyter Lab Connect button to open the Jupyter Lab interface. Find and tap the ComfyUI 8188 button, which will launch the ComfyUI interface in your browser. Now that we have ComfyUI up and running, all that's left is to upload the self-forcing workflow and start creating. And that wraps it up for this guide. We've covered how to get the new self-forcing video models up and running, whether you're using the one-click installer doing it manually or using a cloud GPU on RunPod. It's a really interesting model with a lot of potential, especially with its focus on speed and efficiency. I'm excited to see how it develops. Thanks for watching, and I'll catch you in the next one.